Good morning, good afternoon, good evening, whenever you are watching this video lecture. Thank you very much for joining me today to learn about databases and coding in SQL. The lecture today is about SQL joins. SQL joins combine rows from two or more tables based on a related column or a common attribute. This operation, join, enables the retrieval of comprehensive data from multiple sources in a database. The primary types include inner join, left join, right join, and full join. The inner join returns only rows with matching values in both tables. The left joins includes all rows from the left table and matches rows from the right, with null values for those non-matches. The right join does the opposite, including all rows from the right table, or you can say the second table. And the full join returns all rows from both tables with nulls where no match exists. And also we have self-joins. These self-joins allow a table to join with itself to explore hierarchical or intra-table relationships. While joining multiple tables connects several tables in a single query for complex data retrieval. Each join type serves specific use case, determined by whether you need complete match or partial data inclusion, and requires precise conditions to avoid incorrect results, like Cartesian products. In this lecture, we will cover inner join, left join, right join, full join, and self joins, and also joining multiple tables. And like the previous lectures, we use our university database with several tables like classroom, department, course, instructor, section, teach, student, takes, advisor, time slot, and prerequisite tables. Okay, let's move to the full screen. So for this one, you just press Alt, Shift, and Enter. The first one is inner join. Inner join returns only the rows where there is a match in both tables. It is the most common join type used when you want records that have corresponding entries in both tables. For example, find courses and their departments. As you know, courses are in course table. Departments are in another table. So we need to join courses and department tables where department name matches. And this will return only courses that have a valid department, excludes courses with null departments. So the result includes course ID, for example, title, department name, and department's building. To do that, select course. From the course table, we will get course ID, right? And course title, course.title. Course dot means the title attribute from course table. Department dot department name and department dot department building, right? From course, the course is the one table. Then we will do inner join department on course dot department name is equal to department dot department name. We join two tables, course and department, wherever the attribute department name in course is equal to the attribute department name in the department. And this is the two tables that we join them together. Okay, let's run it. And here is the result. Find courses and their departments. For example, if I want to go for only courses, I will get this one. Select all from course. Right in here, I don't have the building, right? And I have here credit, but I want to have department name and building as well. If I go just only for the department, select all from department, then I don't have the courses. So in order to have both together, we need to make the inner join, and here is the result. The next one, I want to make join between section and classroom using a composite key like building and room number, and find sections and their classroom. So for this one, I need to go for two tables. Select all from section. Select all from section. Here are the information about section. And also I need to go for classroom table. Select all from classroom, right? Here we go. Now I want to find sections and in which classroom they are. And I want to also get some information about the classroom, right? So the output of this one will be sections that are assigned to a valid classroom. And I want to show course details along with classroom capacity, right? So you can see here, capacity is not here, but capacity is here, okay? So in order to do that, we go for an inner join, select section dot course ID, section dot section ID, section dot semester and section dot year, right? Then these are from the section. I need to go for the some attributes from the classroom as well. So classroom dot building, classroom dot building, classroom dot room number, and classroom dot capacity. So the output will give me this much information. So in one table, I don't have this much information. So from section, this is the meaning of relational database. We normalize our tables in smaller tables. Then using these joins, we can retrieve as much as information we want. That's why it is efficient, because we have saved the storage size, right? And it is efficient. Reliably, we can retrieve data. So inner join classroom on what? On the building in two tables and room number in two tables. So section dot building is equal to classroom dot building, and section dot room number is equal to classroom dot room number. So let's see what happened. Here we go. So this is the result: sections and their classroom with capacity and all the information. The next one is left join. Left join, also it is called as left outer join. Left join returns all rows from the left table and also match rows from the right table. If there is no match in the right table or in the second table, null values are returned for columns from the right table. This is useful when you want all records from the left table, regardless of whether they have a match. So let's see, I want to find out list of all courses, including those without a department. So we want to have a table where all courses are there, even though their department name is null value. If a course has no matching department, then department name and building will be null. So let's do it. Select course dot course ID, course dot title, and department dot department name, and department dot budget. Okay, now from where? From course. Then we will do left join department on what? On course. From the course, we will get the department name and matches with the department dot department name. Here we go. You can see these are the courses and department. This course, animal biology, has no department. That's why null value is here. This belongs to the zoology department that in the previous lecture we have removed it, right? If there is no matching, then value of null will be here. Next, I want a list of all instructors and their departments. So in here, we want to get instructors, including those not affiliated with a department. So in order to have one instructor without department, so let's do insert into instructor, the attributes instructor ID, name, department name, and salary. And the values are, for example, I1003, then the name is Brown, the department is null, and salary is 70,000, right? Okay, now we can go for the left join. Okay, so select instructor. We want to have instructor ID, instructor name, and department name, right? So instructor dot instructor ID, instructor dot instructor name, and department dot department name. From instructor, then left join department on. We want to connect these two tables because they have a common attribute, that is department name, right? So instructor dot department name is equal to department dot department name. Let's see. Here is the result, and you can see here Brown is here, but the value here is null because he is not affiliated with any department. The next one is right join. The right join returns all rows from the second table, the right table, and match from the first table or left table. If there is no match, then null values are returned for columns from the left table. This is less common, but it is useful when you want all records from the right one. For example, I want to have list of all departments and their courses. So the output will be all departments, even those with no courses, right? So select department. Select department. I want to have department name. I want to have department building. And also I want to have course ID and also course.title. All right. Then from course, write join department on course. Course dot department name is equal to department dot department name. So you can see here, this is a department in this building, but no course, and that's why you can see the null values. It is useful for identifying departments without course offering. The next one is, I want to find list of all departments and their instructors. So I need to connect instructor and department. I want to return department, even those with no instructors. So department without instructors will have null values for instructor ID and name. Select department.depth name, department.budget, instructor.instructor ID, and instructor.name. From there, from instructor, and write join department on what? Again, instructor department name, right? Instructor.department name is equal to department.department name. So this department astronomy, it appears with null values for instructor ID and name. The next one is full join. Full join returns all rows when there is a match in either left or right. If there is no match, null values are returned for columns from table without a match. This is useful for finding all records matched or unmatched from both tables. For example, I want to combine all course and departments. So select course ID, course.title, department name, and department.building. From course full join, this is the keyword, department on course dot department name is equal to department.department name. You can see null values in both sides. These return all courses and all departments. Courses without departments and departments without courses are included. We have null values in both sides. These null values appears when there is no match. It means one course, no department, one department, no course. Both of them we can see. Or in the next example here, we want to combine all instructors and departments, right? Select instructor.instructor ID, instructor.name, and department.department name. From instructor, full join department on instructor.department name is equal to department.department name. Here we go. You can see both of them, all instructors and departments. We have instructors without department, we have departments without instructor, right? This Mr. Brown has no department, this astronomy has no instructor, right? This is useful for complete overview of instructor-department relationship. The next type of join is self-join. Self-join is a join where a table is joined with itself. This is useful for hierarchical or relational data with the same table, such as prerequisites. This requires aliasing the table to distinguish between two instances. I want to find courses and their prerequisites. Okay, so select, I need to rename it. So I will rename this from course. I will rename it as C1. All right, so select C1 dot course ID as course, C1.title as course title. Let's do one left join we need. So prerequisite on C1 dot course ID is equal to prerequisite dot course ID. Then I have to do the same again. So left join again course with itself as C2. Okay, I rename it. So in here I say C2 as the output, course ID as prerequisite, and C2.title as prereq underscore title. Okay. Then from where, from course as C1. Left join with prerequisite on C1 course ID, prerequisite ID. Then again here C2, course as C2 on prerequisite ID is equal to C2 dot course ID, right? So let me run it. I will explain it again. So you can see here courses, prerequisite ID and prerequisite title. So we use course table twice, right? Once we rename it as C1, second one rename it as C2, right? Then we join through prerequisite to link courses with their prerequisites. So this left join ensures all courses are listed, even those without prerequisite. The result shows, for example, this one has a prerequisite like this one. So this CS 101 is prerequisite for AI 101. The next example here, I want to find students with the same advisor. So for this one, I will make some copies. Advisor, I will name it as A1, another copy as A2, and student as S1, and student as S2, right? Then I go select A1 dot student ID as student1 and S1 dot name as name1. Then the same I will do for the second one, A2 dot student ID as student2 and S2 dot name as name2. And also I want to get the advisor ID. So A1 dot instructor ID. Okay, from where? From advisor as A1. Then I will join this one with itself advisor as A2 on A1 dot instructor ID is equal to A2 dot instructor ID, and A1 dot student ID is less than A2 dot student ID. Then this one again join with student as S1 on A1 dot student ID is equal to S1 dot student ID. And also this one we will join student as S2 on A2 dot student ID is equal to S2 dot student ID. Let's run it. We can see here these two students, they have one, right? These two students, they have one, and it can be printed all together. This self-join on advisor, we did it to find pairs of students with the same advisor. And this condition, this A1.student ID less than A2.student ID, this prevents duplicate pairs and self-match. And we did join with student to get student names, and we show all together. Then I want to show you joining multiple tables. SQL allows joining multiple tables in a single query to combine data from various sources. This requires careful specification of join conditions in order to avoid ambiguous or incorrect results. Here we want to find students, their courses, and their instructors. Okay, select student dot student ID, student name, course dot course ID, course dot course title, instructor.name, we rename it as instructor name, right? Because it's name, but by that name will be the same, so we renamed it. From student, now we have to do multiple joins. So because we want to go student and their courses, so we have to join with takes on student dot student ID is equal to takes dot student ID, right? Again, we need to join by section, right? Because we want to have their professors as well. So on takes dot course ID is equal to section dot course ID, and takes dot section ID is equal to section dot section ID, and takes dot semester is equal to section dot semester, and takes dot year is equal to section dot year. So we have combined takes, student takes, and section here. Now we have to go for course, right? So we join with course on section dot course ID is equal to course dot course ID. Again, we have to find professors who teach. That's why we have to join with teach on where on. So section and teach, they have common column of course ID. So section dot course ID is equal to teach dot course ID, and section dot section ID is equal to teach dot section ID, and section dot semester is equal to teach.semester, and section.year is equal to teach.year. Then again, we need to have another join with instructor, right? To find the instructor name. So instructor on teach.instructor ID is equal to instructor.instructor ID. Okay, that's all. Let's run it. So here we can go student name, course title, and professor name. So what we did here, we joined 5 tables: student, takes, section, course, and instructor. These links student to their enrolled course in takes, and section to course in course, section to instructors on teach, and instructor to their details that we have here. These composite keys like course ID, section ID, semester, and year ensure precise section matching. In the last example, I want to find course schedules with classroom and time slot. Select, I need to have course ID, course title, section, semester. I need to have year. I will get it from section. I need to have classroom, building. I need to have room number. I need to have time slot, day. I need to have a start time from time slot. And also I need to have end from time slot. That's all. Then from course, I will join it with section. Between section and course, we have course ID command. So course section on course dot course ID is equal to section dot course ID. Then we go for left join with classroom on section dot building and classroom dot building. Section dot building is equal to classroom dot building, right? And also section dot room number is equal to classroom dot room number. Again, we will do left join with time slot on between time slot and section. We have time slot ID command, right? Section dot time slot ID is equal to time slot dot time slot ID. That's all. Here we go. We did join with 4 tables. One is course, another one is section, classroom, and time slot. This left join ensures sections without assigned classroom or time slots are included. And we show complete schedules, course details, semester, year, location, and also timing. This is useful for generating a course catalog or schedule. Okay, that's all for today. So join are very helpful in SQL. We should use them to retrieve data efficiently. We need to always specify the join condition explicitly using the keyword on to avoid unintended Cartesian product. We should use table aliases like C for course to make queries more readable and concise. We have to choose the appropriate join type, like inner join for match records only, left join to include all left table records, right join to include all right tables records, and full join for all records from both tables. If we have multiple tables and we are going for multiple table join, we need to plan the join order and conditions to maintain clarity. We have to test queries with small data sets to verify results before running on large tables. It's better to use comments to explain complex joins for future references. There are some common mistakes like missing join condition that can lead to a Cartesian product. It means all rows combined with all other rows in the second table. Incorrect join type may exclude desired rows, for example, using inner join instead of left join. Ambiguous column name in multi-table joins require table prefix, like course department name that we used. Composite keys in join, like section primary keys, must include all components. And also, self-joins require distinct aliases to differentiate table instances. Thank you very much for your attention today. Please practice all and feel free to ask me your questions by leaving a comment below this video lecture. Thank you and see you in the next lecture.